Hello students, welcome to the second lecture on electrostatics. In this lecture, I am going to explain and solve some of the numerical problems on the concept of Coulomb's law. In the first video, I have explained the properties of charges, Coulomb's law and mathematical expression for that, and I have also explained the limitations of Coulomb's law. If you have not seen that, please visit and watch that video, and I have given the link for that video in the description. Okay, now let's solve the problems. So here I have given what is the net force acting on a test charge when placed midway between two positive charges. So here I am considering the test charge Q in midway between Q1 and Q2. The distance from Q1 to Q2 is 2r. The distance from Q1 to test charge Q is r, and also the distance from Q2 to Q is r. So now, according to Coulomb's law, what is the force acting on Q due to Q1 and Q2? Okay, so according to Coulomb's law, we can write the force acting on Q due to Q1 is F1, and that is acting in this direction because since this is positive charge, remember this, always the test charge will be positive, and here I am considering the positive charge only. So between two equal positive charges, since it is positive and this one also positive, the force will be acting away from the charge. That means this pushes this charge in this direction, and the force due to Q2 on Q is F2, and that will be opposite to F1. Okay, so now according to Coulomb's law, we can give the F1 as 1 by 4 pi epsilon naught Q1 Q by R square, and F2 is equal to 1 by 4 pi epsilon naught Q2 Q by R square, right? So then here F1 is equal to F2 because Q1 and Q2 are same. That's why the net force acting on the test charge Q is 0 because both the forces are equal in magnitude and acting in opposite direction. This is both armies, both forces F1 and F2 are equal in magnitude, but they are acting in opposite direction. That's why net force acting on the charge Q will be equal to 0. Okay, next we have the second problem, that is 12 equal charges are situated at the corners of a regular 12-sided polygon. What is the net force acting on the test charge Q, which is located at the center? Okay, so this is very easy concept. So here I am considering a test charge, that is Q, and all the charges are located, like 12 charges are located at the vertices of the 12-sided polygon. See, we have 12 sides, 1 2 3 4 5 6 7 8 9 10 11 12 sides plus 12 charges at the vertices. Now let's consider the force due to Q1 and this test charge will be in this direction. Why? Because both are positive charges. Force due to this one and this one will be in this direction. That is, let's consider F1, and force due to Q7 on this test charge will be in this direction, right? So let's consider that is F7. Here the magnitude of the force is same, but they are in opposite direction. So F1 cancels with F7. Then again, if I consider Q2, the force due to Q2 on this test charge will be in this direction, that is F2, and force due to Q8 on this test charge will be in this direction, that is F8. So both are in opposite direction and they are equal also, so both will cancel each other. In the same way, all the forces cancel with each other because of equal and opposite direction. So the net force is calculated by using the superposition of principle of superposition of forces. So net force is given by F1 plus F2 plus so on up to F12, and if you add all these three you will get 0 because F1 cancels with F7, F2 cancels with F8, F3 cancels with F9, F4 cancels with F4, F10, F5 cancels with F11, and F6 cancels with F12. Okay, so now that's why the net force acting on the test charge Q, which is located at the center of the total sided polygon, is 0. Okay, this is done with this. So now, what if I remove one charge from this? Let's consider this is the vacant place. There is no charge here. What is the net force acting on the test charge now? Force due to all these charges will get cancelled because of opposite charges except Q7, because there is no opposite force here. That's why the force acting on this test charge due to all these charges will be equal to force due to Q7 on this one. So that is K Q7 on Q divided by R square. R is the distance between these two, that is the radius. Okay, or the distance between this vertex and the center. Okay, that is K Q7 Q divided by R square. That's it. Okay, we'll go to the next problem. Okay, next we have the third problem, that is find the net force acting on the charge at vertex C. So here we have three charges. One charge is located at A, one charge is located at B, and one charge is located at C. And the distance between any two charges is given by A. Okay, the distance between these two charges is A, distance between these two charges is A, and this distance between these two charges is the A, and they will form an equilateral triangle. Now I need to find the force, okay, net force at the vertex C. So now first I will find the force due to A at C. So this will be in this direction, right? Because both are equal, this will be Q, both are equal and they are positive also. So that's why the force of interaction between those two will be in opposite direction. So let's consider this is force at C due to A, and force due to B at C will be given by in this direction. So that is FCB. So the net force acting between these two, that means the net force at C because of these two is given by the resultant force. So if we have two vectors and which are making angle theta at the tails, then the resultant vector is given by a square plus b square plus 2ab cos theta with square root. And the same formula I will use here. Now, what is the formula for FCA? So that is K into Q into Q, Q1 Q2 by R square, right? So here Q into Q divided by A square, because the distance between these two charges is A. So FCA is given by K Q square by A square. And in the same manner, force at C due to B is given by K into Q square by A square. Distance between those two charges is A. So that is this one, K Q square by A square, and both are same. See, K Q square by A square, K Q square by A square. So here I will consider these two as F. Both are same. So now the resultant force will be in this direction, right? Since this is the equilateral triangle, this angle will be 60 degree, this is also 60 degree, this is also 60 degree, this will also be 60 degree. So the net force is given by the resultant force square root of f square, because this is f, this is also f square plus 2 f1 f2, that is 2f cos 60 with square root. So now what is cos 60? 1 by 2. So now these two and this one 2 will cancel out. Then I will get f square plus f square plus f square is 3f square with square root. So square root of f square is f and square root of 3. So I will get net force square root of 3 into f. So what is f? F is k q square by a square. So just substitute that here. So this is the net force acting at point C due to charge q at A and due to charge q at B. Okay, so that's it. Okay, I have come up with a new problem, that is, see, there are three equal positive charges are located at the vertices of a square at A, B and D as shown in the figure. Find the net force acting on a negative charge of equal magnitude which is located at point C. Okay, so we have the positive charges which are located at A, B and D. I need to find the resultant of these three forces, like resultant of forces due to these three charges on this charge. Since this is negative, the force of interaction will be positive. Since these three are positive and this one is negative, the force of interaction between due to these charges and this charge will be positive. So now first, the force of interaction between the charges C and charges B is given by Q into Q, that is Q square divided by A square into K, right? K is 1 by 4 pi epsilon naught Q1 Q2 by R square. Here K into Q square by A square. You should not consider the negative sign here. Okay, so then the force due to this charge at D at C is given by Q into Q square divided by A square into K, and force due to this one Q into Q, what will be this distance? What is this distance? We can find out this by using Pythagoras formula. Square root of A square plus A square, how much is that? Root 2A, right? So now K into Q square by root 2A whole square, that is equal to K into Q square by root 2 square is 2 and A square is A square only. Now I have found the force due to B and force due to A and force due to D, but force due to B on this charge will be in this direction. Okay, force due to D on this charge will be in this direction, because since these two are opposite charges, the force of interaction will be positive, and force due to this charge at A will be in this direction. Now I can't directly add these charges, because you can only add or subtract forces only if the forces are acting along a line, but here the forces are acting in different directions. So what you need to do here is first find the resultant of these two vectors that will be in this direction, okay, and add to this force, like find the resultant of these two, okay, then add for this one. So now by finding the resultant by using this formula a square plus b square plus 2ab cos theta, you can find this. So find the resultant of these two forces. So that is, this is similar to this one, so I will consider that as f. So f square plus 2f into f cos, the angle between these two forces is 90 degree. Okay, so what is cos 90? That is 0. So this term will go 2f square, square root of 2f square is square root of 2 into f. What is f? Again this term only, k q square by a square. Just substitute that there. So we will get square root of 2 k q square divided by a square. So now you can add these two forces, because this force is along this force. That means the resultant force due to these two forces is equal to is along the same direction as the force due to A and C. So I can add these two forces. So the net force is given by force due to A and C plus force due to those two charges, like these two. That is the resultant force. So FCA is given by K Q square by 2A square plus resultant force. This one square root of 2 K Q square by A square. If you take common K Q square by A square here, you will get square root of 2 plus of. You can take LCM also here. So if you take LCM, you will get this is equal to K Q square by A square into 2 root 2 plus 1 divided by 2. Correct? That's it. So this is the net force acting on a charge, negative charge, which is located at the point C due to these three charges. That's it.